All right, I don't know if that's coming out on the, can you see it? Can you see the green? Sorry. Can you see the green that coming out? Okay. So the question is this: if the top of my head is 0.03 square meters, if the top of my head is 0.03 square meters, and the atmospheric pressure is 101,000 pascals, what force is on top of my head? What force is sitting on my head? Well, we know that dent at pressure equals rho GH, right? Right? Rho GH. And we also know that pressure is force over area. And I'll prove that. I'm going to finish this problem and then prove that using dimensional analysis. Is that okay? I'll prove it. But let me just finish the problem. This is a very quick problem. So if the atmospheric pressure is 101,000 pascals, and that's going to be force over 0.03 meters squared, what's the force going to be? Yes? 3,030. So the force equals 3,030. And that's going to be newtons, right? Yeah. Correct? 3,030 newtons, which is pretty big. I weigh little less than 1,000 newtons. Can you imagine? My weight, 3 times my weight, standing on your head. Painful. You know, can you imagine what that would do to your neck vertebra? Painful. So why can we, Gabby's looking, feeling her neck. Why is that not an absurd value? Anybody? Any people with biology sensitivity in here? What happens? Why is that really not a big deal? Why is that a surprise to you that it's so big, such a large force on top of your head? Why is that true?
Is the pressure in our bodies
Well, just that we've evolved, we've adapted. Our bodies adapted to those pressures. It sounds simple. It's actually very complicated, but it is actually simple. The answer is simple. It's that our bodies have evolved. How have they evolved? Well, that's a little bit more complex, but the fact that they've evolved to be able to deal with that weight, that's a little different, yeah? Easy? Okay, now, let me prove to you that I can use either equation. Okay? Is that all right? All right. So let me erase this. So what I'll do is I'll write on the board both equations. And we'll try to make this equation newtons per meter squared. Is that okay? Yes? Yes? Okay. Well, rho is going to be kilograms per meter cubed. G is meters per second squared, right? And then height is what? What's height? What's h? What are the unit labels? I know, yeah, what is it? What are the unit labels for height? Meters cubed? Meters squared for height? How tall are you? How tall are you? 6 square meters? What are the unit labels for height? Just meters, right? Just meters. You get that? Just meters. I don't know what they did. Okay. Meters. Right? Easy? So what? So what? I can say this is Isn't that, what is that? Kilogram meters per second, what is that? What is that? Isn't that a force? Isn't that newtons? Isn't it? Right? So kilogram meter per second squared is a force, right? Isn't it? Okay, and then that cancels with that. So what's on the what's in the denominator?
M squared.
Is it going to be m squared, which is an area? Correct? Yes? So therefore, I can say that this is force, kilogram meters per second squared, over area, which is meters squared. Yes? Which is pressure. Clear? So they're the same, aren't they? All right? Yes? We'll come back and do two more quickies. Yes? Didn't we go over these already or no? Did we go over these yesterday?
No, we started to do the oil and water one.
We started to do the oil and water one, but we finished. Do you understand the oil and water one now?
Yeah.
Do you understand the one with the total pressure and the total force on your head? A lot, huh? Okay.